Today, let's look at this infinite integral, indefinite integral. I previously done it before, but today I want to revisit it because I found some interesting phenomenon. So I'm going to use two different methods and reach two different conclusions, two different answers. And the question is, do they differ only by a constant? Let's find out. Method 1. First, I'm going to divide everything by x squared. So 1 plus 1 over x squared. Bottom, I have x squared plus 1 over x squared. That's the method I used previously. So the benefit of doing it, of course, here, I have to require x not equal to 0. So by observing this, I found that what kind of function derivative gives you the top. Right? So if we, first let's completing the square on the bottom. So this integral, so x plus 1 over x squared, completing the square. I'm gonna, there is a plus 2 coming out, right? So minus 2 here. 1 plus 1 over x squared. So could it be possible that this derivative gives you that? So let's find out. So if I differentiate this, that actually gives me 1 minus. Not exactly that. So I'm going to have to look at maybe x minus 1 over x. It's just 1 plus. Right? So which means I have to rewrite it into minus. Right? Since there's a minus, so there's a negative 2 coming out. So I have to plus 2 dx. Right? So that way I can have top, I have, if I let x minus 1 over x equal to u, then all of a sudden I have top, I have du. Right? Du. So that is just du u squared plus 2. So that is simply just factor out 2. I'm left with half of u squared plus 1. So that is half du. That is just square root of 2u squared. Right? That is arctangent of u over square root of 2, right? There's constant here, so just divide by its constant. So multiply by square root of 2. Plus c. Right? So let's replace u back with that. So that is actually square root of 2 over 2 arctangent square root of 2 x minus 1 over x plus c. X not equal to 0. So this time I'm going to use second method, partial fraction method. That is equal. Perhaps I just deal with the integrand first. So integrand become anyway. So denominator 1 plus x4. That is x to the 4 plus twice of x squared minus twice of x squared plus 1. Alright, so completing square. X squared plus 1 squared minus 2x squared. Difference of perfect square. Right? X squared plus 1 minus square root of 2x x squared plus 1 plus square root of 2x. Right? So now I can use partial fraction decomposition. Right? So the integrand is supposed to be 1 plus x squared, 1 plus x fourth. Right? At the same time should be equal to partial fraction. First factor is this, x squared minus square root of 2x plus 1. The other. And notice that both the determinant of this quadratic is already negative. Right, so is this one. So x squared plus square root of 2x plus 1. And top I have ax plus b, cx plus d. I'm going to determine these constants. So, first of all, I say this times that plus this times that has to equal to this top. Right? So, in other words, ax plus b times x squared plus square root of 2x plus 1 plus cx plus d times x squared minus square root of 2x plus 1 has to equal to x squared plus 1. Now, instead of expanding everything out, I'm just going to have a look at the constant in front of first x cube term. Right, what's its constant? Coefficient, I mean. So the only possibility is this times that and this times that. So coefficient is just a and c, a plus c. There's no cubic term here, so equal to 0. Right, x squared term. So this times that, right? Square root of 2 times a, and this times that, b coming out. Also this times that, right? Minus square root of 2, c, and this times that plus d equal to, coefficient is 1. X term is this times that, yes, so a. Also this times that, so square root of 2b. No. X term, yeah, x term, a coming out. X term. Yeah, square root of 2b. Square root of 2 times b. Here is this one plus c. And these two minus square root of 2d equal to 0. Right, there's no x term here. So constant term, what is that? B, c, right? B plus c equal to 1. Right? Okay, so let's work out a, b, c, and d. So here I have a is c is equal negative a, and also db is c is equal to no. No. Here, a constant term b plus d equal to 1. Yes. So here C negative A, D is equal to 1 minus B. All right, so everything is in terms of A and B now. Now I can square root of 2 times A plus B minus square root of 2 times C, square root of 2 times C, plus square root of 2 times A, plus D, plus 1 minus B equal 1. Okay, this, so A plus square root of 2B plus C minus A minus square root of 2D minus square root of 2 times D. D is 1 minus B equal 0. And this time, of course, plus B minus B, plus 1 plus 1. And A should be equal to 0. So which means C should also equal to 0. And so here, so A is 0, 0. Here. B, the square root of 2, negative, negative, positive, twice of square root of 2B minus square root of 2 equals 0. So B has to equal half, right? And so, which means D is equal to half also. So remember, I've turned the integrand into this. So when A and C equal to 0, now I can just have this is gone, B and D are there. So I just need to work out the B is half times that, right? 1 over x squared minus square root of 2x plus 1 and half. So D half, right? C gone, D half, factor out. Maybe not yet. So 1 over x squared plus square root of 2 plus 1. Just need to work out integral of this. So I'm just gonna have to complete the square here. How can I? So work out this and dx, work out that. So that should be equal to half. So x minus half square root of 2 square. And there is this square is half, plus half, minus half, plus half. Right? Also, likewise, x plus half square root of 2 square. Likewise, minus plus half dx. And so this I can just factor out half. I can just factor out half. So half factor out, multiply 2 to this. So I'm going to put the 2 into the square. So square root of 2 square. Square root of 2 goes into here. So square root of 2 times this is minus 1 square plus 1 for this one. Likewise, half, very similar. Square root of 2x plus 1 square plus 1 and Yes. So now I can easily cancel this half, right? They just cancel out. So that becomes arctangent of arctangent of whatever this is, just putting to that here, square root of 2x minus 1. And also there's a constant, so divide by that constant. So 1 over square root of 2. And also that one, similar. Plus 1 over square root of 2 arctangent square root of 2x plus 1. And also plus c. But before I plus c, I have a problem here. So the question is this antiderivative the same as that one using the first method, right? Are they the same? Or do they, like I said, do they differ just by a constant? Looks like they're different functions. But let's perhaps simplify this one, right? So from the trig identity, we have trig identity. There's called arctangent x plus arctangent y is equal to arctangent x plus y over 1 minus x times y. So this is easily verifiable. Just use the angle sum of tangent, then apply the arctangent, inverse tangent on both sides. So not going to go into details. So according to this, we can simplify that. So that automatically, so right, this square root of 2 multiplied by square root of 2, both sides. So this one. So arctangent, this plus that. So this plus that. Twice of square root of 2 times x. And 1 minus x times y. 1 minus this times that is a, what? 2 times x squared minus 1, I believe. Right? So that should equal to square root of 2 arctangent, and this is 2 square root of 2x. This is 1 minus 2 minus 2x squared. That is just, I believe, arctangent of square root of 2x over 1 minus x squared. And also, since I've simplified, so that means bottom cannot be 0. X cannot be plus or minus 1. Right? But before I simplify, I'm okay, I'm safe. Right? This is after I simplify. And also, this answer from the first method, x cannot equal to 0. So are they the same function, just differ by constant or not? This c might be different from that c. But when you take their difference, do they also differ by constant? Now, if we just simply differentiate this, right? So I'm just going to skip over all the algebraic details. So the derivative of this is straight up that, right? And also differentiate this also gives you that, right? Just skip over the details, algebra. So which means they should be equal, just differ by a constant, right? But they don't look like so. So how do we? So first of all, one thing I notice is that this is actually the negative inverse reciprocal, negative reciprocal of this. So why? Because if you take this, right? How do we know it's the negative reciprocal of that? Or perhaps we take that, right? 1 minus 1 over square root of 2, right? Can be simplified x squared minus 1 over square root of 2. That is square root of 2 x squared minus 1. So this is, yes, the 1 minus x squared minus 1, negative, right? So reciprocal, really the negative reciprocal. So that reminds me of the, I'm going to use tangent, definition of tangent. Now, for example, if I say this is the trig ratio, right? Tangent ratio. So this is this. So A, B, C, alpha, beta. So this trig ratio is in fact, if I call this alpha, this arctangent is an angle alpha. Then this trig ratio is the opposite over adjacent, right? B over A. Right, that tangent alpha. Alpha is this arctangent, right? And this, in other words, this is the trig ratio of the negative reciprocal of that, right? Negative reciprocal of that. That is the negative A over B, right? Negative A over B. So, but positive A over B is just tangent beta, right? So negative A over B should be equal to negative tangent beta. So negative tangent negative beta, right? So that makes it. So really, if you take their difference, right? Difference, same coefficient, just ignore this, different c's, different con. So this minus that is the angle difference, right? That is angle difference, this angle and this angle. Alpha plus beta is, yes, so this solves this mystery. Right, so it looks like there's no problem. So mystery solved. So really two different answers, but indeed they just differ by constant, even if you include the c's, right? But the question is still not done, because right now I'm looking at antiderivative when x is non-zero, or antiderivative when x is not -1 or +1. So I want to know their antiderivative at 0, right? But first of all, let me look at the limit as x approaches 0. Does it have a limit? Cannot equal to 0, but could the limit exist? Okay. So looks like when x is approaching from the right-hand side. So if I call it f of x, let limit as x approach 0 from the right-hand side should be equal to, so this will approach positive infinity, and so this negative infinity, this is gone, and this is constant. So overall negative infinity inside. So negative half pi. So negative square root of 2 over 4 times pi. plus c, right? So maybe I say, before I add c, I want to analyze first. Later, I'm going to plus c, right? In the end, I'm going to plus c. So that way, first, let me look at the limit as x approach 0 from the left-hand side. Right? So this part, negative infinity. So this is positive infinity. And positive infinity, so half pi times that. So square root of 2 over 4 times pi. Right here, negative, positive. So it looks like the function is discontinuous, right? There's different limits from. So that way I can redefine a function, piecewise function, g of x, right? So I can just say when x is positive, when x is 0, when x is negative. When it's positive, I can say equal to f of x. I say I plus square root of 2 over 4 times pi. So the limit of this is just, because this is approaching that. So plus this is approaching 0, right? So I define x 0, I define it to be 0, right? Makes sense. So x is negative, I say f of x minus square root of 2 over pi, right? So that way, like I said, from approaching from left-hand side, approaching this. So minus this, approaching also 0. So this function g is actually continuous at 0 and everywhere else, right? So in other words, graphically, this function looks like roughly, let me see, perhaps looks like, looks like this, perhaps. Right, approaching 0. Right, approaching 0, This is this value approaching here, but from the left-hand side, I don't know. Maybe look like this. Yeah, perhaps this, whatever. So positive, this value, right? Previous discontinuous. Now I construct piecewise function. In other words, bring this part upwards, right? Upwards. Bring this part downwards, right? Yeah. Now it's continuous. Right? So we're gonna, in order to find the derivative at 0, g prime of 0. Right? We cannot use this because it has no definition at 0, right? But this does. So we use first principle. G 0 plus h minus g of 0 over h. H approaches 0. And so since this is actually g of h, g of 0, g of 0 is 0. So yes. So then we can use L'Hopital's rule. Because it's 0 over 0. Because when h approaches 0, g of h approaches also 0, like I've proven. This function is actually continuous at 0. So limit, yes, exists at 0. Right? Equal to the functional value. 0 over 0, L'Hopital's rule. H approaches 0, but h not equal to 0. So g prime of h, I can use f prime of h. This is allowed. So differentiate, I'm just going to skip over the details. The derivative of this is straight away, straight up this. Right? And when you look at 1 plus h squared, 1 plus h fourth, like h approaches 0, this approaches 1. Right, so the derivative at 0 is 1, right? And so the derivative, which is the integrand at 0, is what? 1, right? So this has no problem. And likewise, if we want to use this simplified form, we have to use this restriction. If we use this, then we're fine. Right? This is definitely continuous. So this is discontinuous at 1 or negative 1. And we can use a similar strategy, right, to work out the limit as x approaches 1 from the right-hand side, left-hand side. Right? Approaches 1. This constant doesn't matter. Right. So approach 1 from the right-hand side. This will approach 0. Approach 0 from the right-hand side. So this will become positive infinity, I believe. Positive infinity. So the whole thing approaches half pi times this. Very similar. Kind of similar to this one. Right. Approach 1 from left-hand side. Left-hand side, maybe different negative value. So again, we can use the same strategy and construct piecewise function and like shifting the graphs, right? Or maybe a different graph. Maybe just differ by constant, right? Likewise. Piecewise function, then you can use this. And of course, I say the final answer is just the piecewise function g of x I've just constructed plus c. Or, using the same strategy, construct another piecewise function for this one, because this guy is like similar, right? Discontinuous. You're going to have to shift the graphs and make sure the new piecewise function is somehow continuous at these points. So new piecewise function h of x, similar. Similar.